I am Robert Wilson, a radio astronomer who, previous to this experiment, had been mapping the Milky Way using radio waves. My project was to use microwave amplification by stimulated emission, or radiation, to measure the distance between galaxies in space. We were trying to find the distance between galaxies, so the distance between one galaxy and another in the vacuum of space. But we ended up finding cosmic background radiation, which is what we now consider to be evidence of the Big Bang. So our project occurred in Holmdel, New Jersey, at Bell Labs, but we did have some corresponding members from Princeton University, and it took place between 1963 and 1965 is when we published the papers. At the start of our project, we had so some of the world events that happened at the time was Kennedy's assassination, and the start of our project in 1963, as well as what led us in the start of the Vietnam War. And by the time our paper had finished, we had seen the souring of U.S. popularity in the war. And we also were able to see during our project the first woman in space from the USSR. So there was me, and then there was my partner Arno Penzias, who was a German radio astronomer who moved to work at Bell Labs about shortly before I did. And then we had Robert Dickey, who was our corresponding member from Princeton University. So I was one of the two original men on this project before we brought in Robert Dickey. But I was the steady state believer, so I believe that the universe always existed and always will exist, and so on and so forth. So I pushed for us to have more of a just the facts. So this is what we found. This is the numbers that we found. And then we kind of let Dickey's paper kind of make the conclusion of we think this is from background radiation from the Big Bang. But I tried to keep us more on the just the facts approach. So even though at first I did not believe in the Big Bang, our findings eventually showed that show what we now consider to be proof of the initial Big Bang, which is what we consider to be the start of the universe now, based off of the background radiation that we discovered. Our project also kind of popularized the radio telescope, which is now used a lot more at universities today. And so what's currently happening with radio telescopes is China recently created the world's largest radio telescope. That it's about 500 meters in diameter, and you have the NASA has a citizen science project called Radio Jove, which gets everyday citizens to buy a radio telescope and then send all their information to an organizer, and so it's able to put large amounts of radio data taken from all over the world together, so you can map out different things and catch different things, especially looking at the sun and then other radioactive subsolar objects such as Jupiter and some of the other gas giants.